Hello, this is Tom, VA3WBA. I made a short video showing you how to find a headless Raspberry Pi SDRconnect server on your network. A couple days ago, I made a video on how to configure such a server, and one of the issues that I came across was, okay, I put the SD card in the server, and the server got an IP. It's clearly online, but what is this IP? So this short video will give you some hints on finding hosts on your network, and it can be used for headless Raspberry Pi or probably for any other host on your network. I hope it will be useful. So here's the example. I logged into the Raspberry Pi. Of course, I did the SSH for sake of simplicity. The experience would be identical if I had a real monitor and keyboard connected. So here I'm at the prompt and I would do sudo ifconfig. So this is not ipconfig, it is ifconfig. And I press enter. And as you can see, I have access and list of all the interfaces. So there's Ethernet interface, there's nothing connected to it, there's loopback, and then here is my wireless WAN interface, and you can see IP assigned to the Raspberry Pi, which is 192.168.222.12. The second method I would like to present is actually my preferred method. This method leverages the wireless router. So we're going to log into the wireless router and we're going to take a look at DHCP assignments. While we are at this, we're going to create so-called DHCP reservation for our Raspberry Pi. So every time we boot Raspberry Pi, it will receive the same IP address. This is different from static IP address assigned to the particular copy of operating system. To find out the IP address of the router, we're gonna issue command ipconfig, and essentially the parameter default gateway is most likely our wireless router. Of course, you need login credentials to log into the router. So what I'm gonna do is I'm gonna open the browser and I'm gonna log in and show you, how to find your way around. So here is my wireless router and the login screen. This is Hytron. I'm with the cable company. You need to know username and password. So I have this thing saved. So for this particular model or maybe service provider, the login name is CUSadmin. And I'm going to click login and we're going to take a look at the DHCP settings. So here we are. I managed to log into the wireless router. Here you can see the scope options for my private LAN. We cannot see any devices, so I need to press this button here, which says show. I press it. And the first item on the list is our Raspberry Pi with the IP address .12. What is interesting, I created DHCP reservation for it. So you can see that this is DHCP reserved. The DHCP reservations are managed under the DHCP reservation section. So I'm going to click it and you're going to see what I mean. So here is my Raspberry Pi and it is an option to add. However, I already have it on my list. It's with different name. It's with the KX2, but I created it. So every time my DHCP server sees this MAC address, it's going to issue this specific IP address. So like I said, it doesn't matter what the operating system is. It will always issue the same IP address because it's a very specific MAC address, and this MAC address is pretty much etched into the wireless card of the particular copy of Raspberry Pi. Now I would like to discuss the third method, which I would like to employ. Essentially, I would like to scan the network. This scan can be performed with a specialized software scanner installed on the client PC. We would scan the entire network, starting with the first IP. In my case, it would be 192.168.222.1 to the last IP, 192.168.222.12. 252.254. However, in the absence of such a scanning software and skills around it, we can resort to a simpler method, knowing that the Raspberry Pi OS replied to the ping requests. So essentially, we will ping all IP addresses on the LAN network, and we will collect the results. This task would be very tedious to perform by hand, so we will use a little bit of automation. So here we are. What I'm gonna do is I'm gonna paste a sort of pre-configured command to show you how to scan the network essentially in a loop, and how to output only correct results. So here is the line. Essentially, it's a for next loop, and we're gonna do from 1 with step 1 to 54 steps. We're gonna do ping, just one ping, for the IP address 192.168.222.i, and that's our variable. And then we're gonna find a TTL string. So essentially, you're gonna see the result now. So you see if the ping was successful, we're gonna see that there is a reply from, because there is a string TTL in it. If there is nothing, we're not getting this line, so we can ignore lines from, let's say, 2, 3, 4, 5, 6, 7. And I let it go in, and but again, we have to then go through the results by hand. Oh, here are two hosts, 11 and 12, and I know that 12 is our Raspberry Pi, but we wouldn't know. That would be the purpose of the exercise, and we could wait for it, but I show you even easier way of achieving this. So the easier way would be to take the output of the routine and collect it into the text file. So here is the edited line, and essentially I'm sending the output to the network scan txt file. So I'm gonna run it, and it pretty much does the same thing, except sends results to the file. So I'm gonna stop the video, and we're gonna take a look at the file when this thing finishes. So the scan has finished. Now we're gonna take a look at the results. So here we are. This is the output of the file. So I know that the IP address .1 is my router, 26 is my workstation, and there are two other IPs, 11 and 12. And at this point, I could give it a shot using PuTTY and try to connect to 11, try to connect to 12, and see if these are the Raspberry Pi computers. But we're gonna make it a little bit more complex. I'm gonna actually scan it one more time, but this time I'm gonna try to see if port 22 is listening on the device, because we know that SSH server, the secure shell, runs on port 22. We're gonna use telnet. We don't care that we cannot connect with telnet. We just want to see if there is any echo coming from this port. So here we're gonna run scan one more time. This time, like I said, we're gonna use telnet. So here is the line. We know that our IPs, we had two IPs, it was 11 and 12, but I'm gonna scan it from IP 10.10 to IP.13. And what I'm trying to do is I'm gonna try to telnet to each of these hosts. So let's run it. So we can see the first IP, it's testing IP 192.168.222.10, and it's trying to connect. Of course, there is nothing there, so this process is gonna time out. But the interesting thing gonna happen when we get to the IP 11, and you can see it in a header. It says telnet 192.168.222.11, and we know that this is some sort of SSH. So here we're gonna type in quit. So that would be good candidate, and it says Raspbian right there. And there is another one. This one says Debian Linux. So that's another. That's actually our Raspberry Pi, so another good candidate. So I'm gonna go quit, and then it's trying to connect to the last IP, and this is just And this is just as an exercise. It's going to, of course, time out. But this is essentially how you could scan your network, narrow down the number of IPs to test, and then try to telnet to each IP automatically. If you have a lot of IPs, if you have just two, then try your PuTTY on the first one and then try a PuTTY on the second one, and one of them should work. So I hope that was easy enough, and it will help you to install your headless Raspberry server. Thank you very much. Please subscribe and like.